Hello. Okay, so we are officially done with section 1.1. So we are done with all the math concept review and we are starting on some chem. So we're going to start talking about matter and its properties. We'll talk about chemical versus physical properties of matter, on also changes, because properties and changes are not the same thing. We'll talk about a little bit about the structure of the different phases of matter, and a little bit about pure substances versus mixtures. So, through here. All right, we're going to start with our physical states. So, I am sure that you guys are familiar with these. Again, this is probably a little bit of a review from physical science here. So, brushing up on some information at the very least. So, we know that solids are going to be regularly repeating. So they're going to be very low energy, solids are. So you have all these particles are right next to each other and they're vibrating back and forth and up and down in all directions. So they are moving. So any solid is moving. So even the dust, like if you take your finger and tap it on your desk, technically none of those particles are touching one another. They're very strongly attracted to one another, so they stay close by, but they're really all moving, all those little particles. There's actually a theory that if you touch an object enough times over and over and over repeatedly, that your finger and the object would become one, and you'd be able to put your hand through a hard object like a desk or a wall. That would take millions and millions and millions of repetition, but that is a theory. So with the solids, just remember that this is your lowest energy. They are moving, but they are firmly in place, so they have a definite shape and a definite volume. Liquids, you're adding a little bit more energy here, actually quite a bit more energy. So to liquids, they're have enough energy between them that they're moving around. They're still attracted to one another, so they're going to stay together for the most part, but they are moving around a lot more quickly. So think of this as ice. It would be your solid. Now you've melted it into water. These particles are moving around pretty quickly. So we have a definite volume, but an indefinite shape, so the shape can easily change. We add a lot of energy to a liquid and we turn it into a gas. So now these particles have so much energy that they are not necessarily they're still attracted to one another, but their attraction is overwhelmed by the energy that they contain. So the energy is so high that it's pushing these particles in all different directions, and they are no longer, the bonds between them are no longer strong enough to keep them together. So the gases will expand into any container that you put them into, because they're not as strongly attracted to one another anymore. So they don't have a definite shape and they don't have a definite volume. Then, this is where things get a little weird. You add even more energy, and like a lot of energy, massive amounts of energy to a gas. You turn it into a plasma. Okay, so this is an extremely high temperature, high energy situation. It's where atoms begin to lose their electrons. So there is so much energy that it's literally breaking down the structure of the atom. So the mixture of the free flying electrons and the nuclei is the result of plasma. So one example of plasma that I'm sure y'all have experienced is lightning. Another example would be putting a grape in a microwave. So don't do this at home. But let me see, I'll pull up a video here for you. But if you put a grape in a microwave and you slice it right down the middle, it creates plasma because you're energizing the particles inside of the grape so much. I'll insert that video beneath this one so you guys can check that out if you would like to. It's kind of funny. So there's a little kid in there. When we talk about chemical properties versus chemical changes, that has to do with some of the states of matter that we have. That's also tied into the strength of bonds as we move through, and also the different types of mixtures and things like that. So there's a difference between a property and a change. It's both for chemical and physical. So a chemical property is going to be a substance's ability to do something. Okay, so combustibility. So if something can catch on fire or it can ignite or explode, that would be a chemical property. So another one would be oxidation or rusting. So if something can oxidize, that is a chemical property. On the other hand, if you have something that's physically changing it, like it's changing it on a molecular level, that would be your chemical change. So something happening to a substance that is irreversible in most cases. So some examples are down here. You have your carbon and your oxygen. So we put our carbon and oxygen together and create carbon dioxide. That's not easily reversed. That would be a chemical change. So something having a chemical change would be that it's permanently altering it. So I have mixed two liquids together and created a solid. That would be a chemical change. Whereas a chemical property could be that now these two liquids that are mixed together have the ability to catch on fire. So that would be a chemical property. Physical properties, on the other hand, are usually much easier to identify. So a physical property is going to be some kind of quality that you can actually measure. So it's going to be something like the boiling point, the solubility, freezing point. Can it be reshaped? So things like that are physical properties. A physical change is going to be talking about the way something looks, feels. It could be reversible, but a new substance is not produced. Okay, so melting ice into water, that's a physical change. So that's not altering the water. It's still water, whether it's solid or liquid, but it is physically changing the way it appears or it feels. You can tear a piece of paper in half. Is this reversible? No, you can't untear a piece of paper, but it is not changing the chemical makeup of the paper. You're just changing the way it looks. Again, hammering aluminum into a sheet, so you're thinning it out. You're changing the shape, maybe the way it feels, but it's not changing actually what it is. So the act of hammering something down, hammering metal down into a thin sheet, would be a physical change. But the property of malleability, which is hammering things into a thin sheet, the property of malleability is describing the quality that can be measured. So that would be the difference between these two. So another example, a property of paper could be that you can tear it. It's tearable. And then the change would be that you actually tore it in half. So here's just some other examples. We've got, oh, sorry, someone just walked in. Okay, so we've got substance here that is being heated. We have mercury oxide. So just the mercury oxide by itself, some physical properties that it has, its color and its shape. Okay, so it is red or an orangish red color. It doesn't have a smell. It's a solid. It's not really soluble in water, so it's not going to dissolve. Some chemical properties that it holds is that it will decompose when it's exposed to light or it's heated, and it will break down into its components of mercury and oxygen. So these are some chemical and physical properties that have here just for the mercury oxide. For the oxygen, once you have heated up the mercury oxide, now we have a colorless, odorless gas that is soluble in water. Those are some physical properties. Some chemical properties are that it is extremely flammable. It supports combustion, and it can react with many different metals. So up here we have mercury in the top corner. So again, some physical properties of mercury. These are looking at things like there's a pattern here. So we've got like color, the way something looks, feels, smells, that kind of thing. So mercury is a silvery white color. It's a liquid metal at room temperature. When it's a solid, so if you cool it down quite a bit, it does become a solid. Mercury is ductile and malleable. It can be cut with a knife. So that means that we could stretch it, we can smash it, you can change its shape very easily. Chemical properties for mercury is that it forms alloys with most metals. Okay, so that means it's gonna chemically bond to other metals. It combines easily with sulfur at normal temperatures, and then it reacts with nitric acid and sulfuric acid at certain temperatures. Also oxidizes. Okay, so you do have some chemical properties. So just identify the difference in these. So mercury, these are things that are just basically descriptions of whatever the substance is. And chemical properties are talking about ways that the chemical can be changed. So here's how we would tell. How do you know if this is a property of chemical property or a physical property? So this little chart is good to use for this. Are these properties determined without changing the identity of the substance? If the answer is yes, you're not changing the identity of the substance, then it's a physical property. If your answer is no, you have changed the identity of the substance. So I burned a piece of paper. It's no longer paper anymore. It's in its components. Then no, it would be a chemical property. So these are some examples of that. So how would the substance react to the presence of air, acid, a base, water, other chemicals? And then on the other hand, physical properties. So these, again, they are not changing the identity of the property or of the substance. Does the property depend on the amount? Well, then now we have new vocabulary. So we're going to have intensive physical properties and extensive physical properties. So the green here, intensive physical properties, the amount of the substance does not matter. So it doesn't matter how much you have of it or how little you have, this property will not change. So things like color, any definite known constants like the melting point of water into ice into water is not going to change no matter how much water you have. So the melting point, boiling point, those things don't change. Density would not matter how much you have of it. So if you have a huge chunk of pudding and then you have a small bowl of pudding, the density would not change. It wouldn't matter. On the other side, you have blue over here, the light blue, the extensive physical properties. They do depend on the amount of the substance. Okay, so these are, again, physical properties, things like mass, volume, length, shape. These things will always change depending on how much you have. So you want to start at the top, start with the properties of matter, determine whether it's chemical or physical. So did you change the identity of the substance? Yes, it's a chemical, or no, it's going to be a physical property. And then once you go down beyond that, you can then further categorize your physical properties into intensive versus extensive physical properties. Last thing we're talking about is classification of matter. So I'm sure you all are familiar with homogeneous versus heterogeneous substances. Mixtures would kind of be at the top of that umbrella. So a mixture is going to be two or more kinds of matter. They retain their own identity and properties, and they can usually be separated. So a mixture, it can be uniform or not uniform, but it's any conglomeration of things put together. So the coffee I have every morning, I have almond milk in it and a sweetener. So that would be a homogeneous mixture because it's uniform in composition. Okay, so you can't, once I mix my coffee with my almond milk and my sweetener, you can't see the pieces in that. It doesn't really settle out if it sits for long enough. It's mixed together well. But there are definitely on a molecular level made up of different things. So if you zoomed in on my coffee and looked at the molecules inside there, you would see water molecules and all the way down to caffeine particles and the different parts of the makeup of almond milk and all of that. So definitely more than one thing in that. So that would be homogeneous mixture. So it's uniform in composition. Heterogeneous is going to be not uniform throughout. So you're going to be able to see the chunks inside of it. You're going to see the different layers maybe. And we'll talk more about that soon. But just know the difference between those. And then a pure substance is completely different from a mixture. So a pure substance has a fixed composition and every single sample is exactly the same. So pure substances normally are going to be just one element off the periodic table. So gold, if I have pure gold, every sample I took of that, if I cut it up into 1,000 pieces, every single sample would look exactly the same because it's a pure substance. Water we know is made of oxygen and hydrogen. Obviously that is more than one element, it's two elements, but a pure sample of water, any part of that you take out to sample will look identical. They will all be water molecules. Same thing with sugar, table sugar. Every single piece of that and any little particle you picked up will be exactly the same. So know the difference between those. A mixture is going to be a blend of things. So several different kinds of matter or several different elements mixed together, several different molecules mixed together. And a pure substance is going to be just one type of thing throughout. So it can be a molecule, but it would be something like water or sugar, that the entire substance is only that one type of molecule. So again, another little chart here to help. So within matter, we have pure substances and we have mixtures. So within a pure substance, it's either going to be a compound. So every single thing in here is this compound, or it'll just be one type of element. On the other hand, we have mixtures. So that is going to be broken down into homogeneous mixtures, where everything is mixed together evenly, and heterogeneous mixtures, where we have distinctly visible pieces. And that's it for the notes today. They are short and sweet, so please let me know if you do have any questions. But basically, we're just reviewing those chemical and physical properties and changes, and then the types of matter. So we're going to do a lab today, and you guys can find that information under the assignments tab.